Hi everyone, today I'm talking to Scott Miller of Cinch Connectivity Solutions. We're going to be discussing high-rel interconnects and the attributes they need to exhibit. So Scott, power and data need to be transported through any electronic system, but when you're talking about mission-critical applications, they clearly need to have much more high reliability and operational, sort of long-term operational sort of performance. So, and at the same time, there can be sort of acute sort of resource constraints to deal with. So maybe you could sort of tell us a bit about that.
Yeah, I think obviously as we go through the world and we have different applications and things of that nature out there in mission critical marketplaces, military, aerospace, defense, medical, all sorts of other markets that have the demand for high reliability, high performing, long lasting product lines, and thinking specifically in the interconnect space as we talk about electronic signal and electronic power, electrical power passing between different systems. So they're communicating with each other or they're responding to each other. That type of, there's just a long history of it, but also it's never ending. And those product or those applications are just, really, consistently looking for better and more, and improvements to existing type of ways to connect between the various systems in the field and those type of things. And so it's we've been making connectors here at Cinch we've been in business for 105 years, started in 1917, 106 years, I guess now. And we started in a different marketplace, but we evolved into connectors many years ago, probably 60, 70, 80 years ago, and have been focused on interconnect products since then. And an area that we've focused in on was really these high critical, high reliability applications. And how we achieve it is through really tried and true methods of doing of developing the right materials, developing the right capabilities of the product. We're using materials that are been in use for a long time to accentuate the temperature range we need to focus on, which typically tends to be in the harsh environment world, critical application world is, we fall in the negative 65 degrees Celsius up to 200 degrees Celsius. And things in between. Obviously, not every application demands that, but you also look at, the environmental aspects of it, the environmental resilience of the product. And so you need it to seal in application so the product doesn't get, penetrated by whether it's water, liquid condensation, dust, storms, whatever it is out in the field. And so you have to have those appropriate sealing capabilities of your product when the interconnects are mated, the cables are mated to the box, or cable to cable connections are happening out there in the field. And so it's, we have that type of performance. Typically IP67 is weatherproof, and IP68 is a little bit more water resistant. And we have products that fall in those categories if you talk about ingress, protection. And then you have the attributes of just the electrical performance itself, and it doesn't always have to be electrical. It can also be optical as well. And so we have products that fall in both in the critical application, the harsh environment application. So the connectors and interconnect products, the cable assemblies and such that connect to each other. So I'll stop there and we can pivot to the next part of the conversation, but for sure.
Yeah, but we can look at a few examples then of where that's important. So obviously, as you said, I mean, anything once it's deployed in the field by nature, then if it's mission critical, if something happens, it could be in a remote location where it's going to be difficult to replace it. It could be something where if that's, that connection is no longer there, it could be costly in terms of operational downtime. And as you said, then you've got to deal with extreme weather conditions, extreme heats, exposure to potentially dust and stuff, and water and stuff like that. So there's clearly, and if the interconnect goes wrong, although the cost of the interconnect is not necessarily that expensive, the cost penalties that could result by that failing could be huge. I'm assuming, especially in some of the applications you're involved in.
Yeah, for sure. And I think if we were to kind of use a few examples of those applications, you think about the soldier wear out in the field. You think about the space applications, satellite systems. And you think about even some aircraft and those type of defense applications or commercial aircraft applications, obviously critical for products like ours to function, and be as reliable as possible. And, in the real critical parts of real critical applications out there, they try to build in some redundancy so they're protected in case something happens. But in some areas, there's not as you can't just have, a soldier carrying, a laptop and a GPS system and a radio and all sorts of other communication devices and have those connected up and just say, okay, now I need 2 of everything, right? Or build in some other way to have redundancy there. So, they rely on the products like ours that have been around for decades, that have proven to be worthy of these applications, sustain and maintain their performance requirements in these applications. The high temperature, high vibration, high shock, high temperature or high thermal, high capabilities, and so many other attributes, the mating cycles, the again, and then the electrical or the optical type connection that needs to happen there, whether it's a high voltage product or it's just passing some traditional signal, or it's RF, radio frequency, high frequency applications. We have products that have been, that we work with and have made and manufactured for many years in the RF space. So, there's just so much that that we're relied upon, and it is good. It's good to feel that way. It's good to feel that way with your customers, and they know that what they're getting, what they're asking you to do, asking you to ship them and them to utilize in their applications. It's very satisfying, gratifying. However, it's also pressure. We want to make sure everything that we do is thoroughly manufactured to the detail we need it to be manufactured, thoroughly assembled to the detail that we need it to be assembled at, and thoroughly detailed at the inspection points and the testing points before the product gets out in the field. And they need to do their own due diligence as well once they put it in their system. And so, all these things kind of add to making sure everybody's comfortable before the product gets out in the use. And again, it could be, a satellite going up into space. It could be a soldier putting on his pack or her pack to start her event that she's going to undertake, and those type of things. And even some applications, like I said, aircraft, and even some of the newer applications like the electrical vertical takeoff and landing markets, as that's evolving in the eVTOL space. And they're looking for critical applications. You got people that'll be flying in vehicles that look like helicopters a little bit, but act like airplane a little bit, and kind of a little bit of a hybrid between the two. And they're looking for high reliability, high capable, harsh environment interconnects as well to satisfy those requirements.
Okay, let's delve into some of the application examples you just mentioned there. So maybe let's start off with satellites. Now, I'm assuming satellites, especially sort of the more compact nano satellites and CubeSats, as you said, you want to have redundancy in systems, but if you've got a lot of space constraints and there's, if you've got a small, say 1U CubeSat, you're not going to be able to fit that much redundancy into the system. So then you need more reliability. So obviously space constraints are important. As you said already, you've got to have robustness of the solutions as well. So in terms of satellites, what are the sort of maybe the key things that you would say are the priorities in terms of what you need for a connector?
I mean, similar to what we've talked about, and
Yeah,
so size and weight are very
yeah,
critical to, and you've heard the adage of swaps, size, weight, and
yeah,
power. I like
yeah.
swaps, which is size, weight, power, and speed, because speed is so
Okay.
important in today's
Yeah.
electrical world. And if we're not doing things at high speed, when we're not communicating fast enough, and
Hmm.
so the same thing kind of plays out here. So what do we need? I think in the CubeSat world and the nanosat world of satellites, what they build their redundancy in is having many of them up there. And so if something fails on a CubeSat,
Yeah.
there's several backup sats out
There's a
there.
constellation with
Yeah, and
multiple.
so you
Yeah.
can't
Okay.
really build the redundancy into the satellite
Design
itself,
itself.
but you have it
Yeah.
in the constellation. But
Mm.
but to that point, though, things. When I say redundancies, things are there to protect everybody out there, whether it's a soldier or an aircraft or a
Hmm.
satellite or anything like that. However,
Mm.
again, they can't build redundancy to everything that is
No.
done,
Yeah.
and it's just really for the handful of real critical things that cannot fail that you try to build that in there, but the
Mm.
rest of it still has to function. And so
Yeah.
again, sometimes there's cases where an application where you think about a satellite, and maybe it's telemetry or trajectory or
Hmm.
things of that, where it's moving around if it needs to move around, or it's just communicating back and forth between space and whoever owns that or whatever is managing that satellite system.
Yeah.
There's criticality, of course, to that, and you can't have it fail, but there's certain aspects to a satellite that, if something goes wrong, it's like, okay, fine, we shift over, or, we utilize something else to get us there. But to your
Okay.
point, I think the most important thing is that the manufacturers, the OEMs out there that are developing these technologies, especially to the satellite side of the world, they're looking for people that have the heritage. And we've
Okay.
been doing, Cinch has been doing product for space applications since the 1960s. So when you go
Hmm.
back to some of the original days of us getting, the globe getting things out in space and putting actually, people in space,
Yeah.
we've been part of that heritage. And so we have a very lengthy exposure to it and track record of
Okay.
supplying the product that were needed there. And again, when you have standards in which you can work within, to work within certain applications, for product, interconnect product, and wire, cable, connectors, the whole gamut.
Yeah.
And so those drive some of the things that uh, we need to deliver to.
Hmm.
But we also try to make sure that, again, that how you go about designing, how you go about manufacturing, how you go about inspecting and testing your product is so
Mm.
paramount to making sure that no piece leaves the building that may cause a challenge out in the field. And so it's important that we keep that in mind.
Yeah. So you mentioned obviously you've been involved in the space side of it for many decades now. So and obviously space is changing a lot now. It's going from the big agencies like NASA and ESA doing the majority of the stuff to new entrants into the market and much more commercial space and also sort of university projects and stuff like that. There's a much more of a democratization there. So you have that heritage coming from working with the likes of NASA, but are you now also getting involved in a lot more of these commercial projects as well?
For sure. Yeah. The
Okay.
the using the term privatization, if that's the right phrase that's used
Hmm.
out there in terms of privatization of the space
Hmm.
market. Yeah. So it's been very interesting. Obviously, the satellite world has been mostly, to your point, NASA, ESA,
Hmm.
et cetera. But there's been other players in that space for satellites, but you utilize the NASA's and ESA's to get your satellites up in space.
Sure.
But you're still working with people you wouldn't consider kind of direct government contractors. So
Yeah.
you have people that are working with that are a little bit more, I guess, commercial
Commercial. Yeah, that
companies
makes
type
sense.
of thing.
Yeah.
However, but
Mhm.
now we have people doing the launches, companies that are
Yep.
doing the launches that
Services. Yeah.
are not NASA or ESA,
Yeah.
that are, all over the place. And it's been interesting to see that evolution over the last, 15 years or so. And it's going to continue just because there's just more demand for it. And it's probably a good thing too, because otherwise we wouldn't be accomplishing some of the things that we are accomplishing in the space market, especially on the satellite side, if
Mhm.
we just relied on, the entities we've discussed that were kind of leading the way for so many years. And so that's been a real interesting aspect to see that evolution. And, our approach to it is always the same, though. If a customer's requiring, depending on the application, depending on what type of electrical or whatever type of performance they're looking for, we likely have the product that they need.
Yeah.
And, we would certainly want to engage with them. And we do engage with some of those companies already. And, we want to show them what our heritage is, what our capabilities are. And typically that's, a quick selling point. And then, you're engaged with the applications engineers or the design engineers, and you're really focused on trying to come up with the right solution for that application or that project or that system. And it's, typically it's things that fall within our core competencies. And so it's been a lot of fun to, see this broaden out, and talking to, customers at some of these other type of companies out there, that the private side of the world, if you will. And they have the similar type mentality. They have the similar type requirements.
Yeah.
But they've also working so much at a such faster pace
Okay.
than how NASA and
Would
or
have done in the
the
past. Yeah.
European Space Agency worked, as far as my experience with them. And so that, I think, is the biggest change. And they're just trying to do so much more. But I tell you what, you would think, oh, is there some sort of maybe lightening or lessening of the standards and the criticality approach
Uh-huh.
because of the pace they're working at? And
Yeah.
to be honest with you, it's very interesting to me. I'm not seeing that at all. I'm seeing
Okay.
even a more heightened, a hyper awareness to these companies out there, because they know that, they screw up,
Yeah.
they're out the market, right? So a lot of eyes are on them. And so it's just been a lot of fun to kind of see that. And the requirements haven't really changed, and the approaches haven't really changed. And so it's good, though, but there's more people involved because there's just so much more that we want to do up there.
But I think, as you say, it's interesting because obviously they can't afford to make mistakes, for have things that could damage their reputation. If you're a company like SpaceX, for instance, just to give an example, everything that company does is being scrutinized in the media all the time. You have, sort of, as you mentioned, launch service companies. If they screw up, their reputation is going to be lost, and it's going to be very hard for them to to get that back. So I guess the need for reliability is just as great, and they need to be just as diligent with their testing and their sort of component selection. I guess similarly, you mentioned eVTOL, and I guess that's the landscape there is a little bit similar to what you're talking about with new space, because you've got new entrants into the market, startup companies that are coming up with electric aircraft. Basically, they're not necessarily the established firms. Their way of dealing with it, is probably not the same as the longest standing sort of players in that market, because it's a totally different sort of application that they're looking at. So, I mean, we touched on a few things. Obviously, satellites, it's, you need to limit the space. You need compact components. You need to have to deal with extremes of temperature. You need to have the ability to deal with shocks because of the launches, etc. But aviation, I guess, is similar. It's lightweight components, compact form factors. Yeah, redundancy if you can fit that in. But is there also things like, having connectors that can handle power and signal at the same time? So they've got like sort of, a hybrid approach that will save space in the system design.
Absolutely. And
Okay.
and I think even more critical than satellite, these eVTOLs and general aircraft or aircraft in general, military or commercial, fuel consumption in vehicles, even on the ground, if I may say, tanks and
Sure.
and everything. Weight is so important. Weight's going to drive,
Yeah.
how much fuel efficiency you have, and
Mhm.
every ounce of fuel that you can save, or
Yeah.
every extra mile you can get out of fuel because the weight's a little bit lighter, is
Sure.
just, it's critical to the economics of that, and the viability of that company or that product or that, type of market. And so, so lightweight is really critical to them. Obviously, again, sustainability, reliability, those are very critical to, these companies. And to your point, it's similar. eVTOL, eVTOL is new and emergent. You've been around a little while, but it's kind of that privatization of the commercial aircraft
Yeah.
industry. Whereas we didn't have NASA and ESA, but we had Boeing and Airbus.
Sure.
Became the two big ones in the commercial
Yeah.
space, and there's obviously the helicopter companies out there as well.
Sure.
But this is kind of a hybrid between that. But anyways, you have very interesting companies that are investing in this world, and even some of the major airlines are investing in this. Even the U.S. Air Force is doing some investing in these type of vehicles because they see the benefit. And I'll get to the power and signal side of this in a moment, but I just wanted to bring to attention that, one would say, okay, well, why don't they just make some more helicopters, right? Instead of these eVTOLs, because we're essentially using the helicopter infrastructure to run the eVTOLs in terms of the landing pads, the flight patterns,
Yeah.
the altitude in which they fly. But it's what I've learned over the past several years is that helicopters are absolutely a bear to learn how to fly properly.
Sure.
As you can imagine, you got a joystick and you're trying to do, all the things that you need to do to balance these things. And it takes, thousands of hours of practice to become a licensed helicopter pilot. And they're just tricky. And they're volatile, not volatile, but they can be, they're not as maybe stable or something like that. But these eVTOLs are designed to kind of, be much easier to fly. Take, even thinking of many years down the road, the autonomous eVTOL.
Yeah.
We're flying drones right now, right? So from the ground, and so you could, see that happening, and we're going to be, driving vehicles without, people really driving them, type of thing, in some not too distant future. And so maybe the evolution goes there too. So having said that, it's just the dynamics of these is making a lot of people's ears perk up, because they're saying, what can we do with these type of things besides just maybe fly some people around some metropolitan areas? People are talking about first responders, getting, people quicker to the accidents, or getting people from the accidents to the hospitals, or getting the firemen and women into the battle quicker by taking them via rather than helicopter, but through these eVTOLs. So first responders and police and those type of things, trying to utilize them as well. And then the military utilize them as well, rather than have some of these really expensive high-end helicopters. They could find an area in their mass vehicle approach of aircraft and ground vehicles and helicopters and fit in these eVTOLs as well. But back to your point, these eVTOLs are really because of the electric approach to the the entire thing in terms of running it through electricity rather than through fuel. power is a big thing, and
Sure.
weight's still a very important thing. So to your point, there's really a neat dynamic there, in that they need an increase in power to support these type of vehicles, but also they want to package things as condensed as they can for the weight savings. And so
Yeah.
we have products that can be, whether it's a power connector with optical signaling.
Yeah. Okay.
We have hybrids there,
Hmm.
in terms of like an expanded beam connector, or a physical contact optical connector that comes together. We can run some electrical copper connections through there as well to run medium to high power. Um, but also, even as the hybrid you speak about, where you have high power contacts
Hmm.
in a connector, or connections in a connector, you can also have some low power, uh, higher speed signal type contacts
Signals
as
as well.
well. And we
Yeah.
have several product lines that kind of bring that hybrid view and hybrid availability to the customer base.
Just touching on that point there, though. So as you say, because of the nature of, I don't know what you'd call fly-by-wire,
Mm-hmm.
it's more important to have optical high-speed connections in a lot of cases then, rather than copper connections. Would you say that was, yeah,
I would say
predominantly the
that would
case?
be the case on
Okay.
the signal side, of course, not non-power side.
Yeah, yeah, absolutely.
For
Yeah.
the bandwidth, yeah, I mean, the old adage is, for the size of an optical wire, if you will, that's just
Mm.
basically the same diameter as your hair.
Mm.
Um, you need a copper cable that's the size of a fist to
Okay.
handle
Yeah.
that amount of bandwidth. So
Yeah.
everybody's like, what the heck are we doing? Why are we not converting everything over to optical? And there's reasons for that, and that's really the case is that optical is getting better and consistently improving, but we just haven't found the best way to field service optical as well
Okay.
as you can field service copper. And of
Yeah.
course, some of that comes from the fact that we've been field servicing copper since the 1930s and 40s, and we've
Sure.
nailed that down, and we've got the interconnects exactly how we want them to. And we have the tooling, we have the assembly instructions, we have the way that the technicians are testing things and seeing the problem and doing the repairs that need to do. You can repair fiber, and there are fiber optic type products that are more, or that are less needed for service and field service.
Mm.
But when it comes down to it, it's a much trickier approach to the serviceability of the product. And so what a lot of people have done is they've said, okay, well, how can I still utilize optics? And that's
Yeah.
really coming to the non-critical side of these type of applications. So if you think about eVTOL,
Hmm.
and especially on the commercial side of eVTOL, they're going to want some in-flight entertainment on these vehicles. They're
Right.
going to want some
Yeah.
of things, so when you think about in-flight entertainment, you think about maybe the air conditioning,
Yeah.
maybe some of the electronic features, excuse me, of the vehicle, which if they need field service, it's okay. It's something that they
Yeah.
can fly without it for a little while they do the
Sure.
service that's going to take a
Yeah.
little bit longer.
It's not
Um,
endangering anyone's life to do that. It's a comfort feature that they can live without until that's repaired, basically. Yeah.
right, and
Yeah.
so the approach there is, you can't just ground that vehicle for an hour and then come in and fix what you need to fix when it's an optical approach to the connection.
Okay.
So you'll have to go and you'll have to maybe make a new assembly, and it might take you a few days to
Sure.
do that type of thing. And they'll
Yeah.
build the infrastructure for it, right?
Hmm.
And they have in some applications that are using fiber in areas and copper in others. But so they'll just have a little bit different approach. So they'll just say, okay, well, we're not going to have in-flight entertainment for this for a couple of days while we get this system fixed through
Yeah.
that, versus if it's a copper connection and it's a little bit more critical application, obviously they're going to want to go and fix that within the whatever time frame they can, in minutes or
Yeah.
hours, rather than days or maybe a week or two, while they try to do that. So but again, I think the capability of these of these interconnects is such that it's always evolving, and it's a lot of fun to see it and witness these new markets come about. Space, well, not new for space, but just the expansion of space,
Sure. Yeah.
and the volume of satellites that are being put up, and then the eVTOL market as that's growing, and several other applications out there that are just a lot of fun to see the evolution of them. And just to circle back on that satellite comment from a moment ago, we've launched in the last 2 years more satellites, and this is a global view. Humanity has launched more satellites in the last 2 years than we have in the previous 65 years combined.
Wow.
And that's not stopping.
I knew it had gone up a lot, but that's a pretty crazy figure,
we
isn't
weren't
it?
putting up thousands of satellites a year type of thing, more in the dozens and that type of thing. But now we're putting up hundreds and maybe even thousands a year. Yeah. And that's, again, my main point there is that's not stopping. They're not slowing down. Obviously, we're going to hit a point where we've got it all covered, and then it's just about maintaining and making improvements and bringing new things to that market, such as not just bringing Wi-Fi to the world in the low Earth orbit constellation of satellites that people have been developing, but really it comes down to then they're talking about direct-to-device connection as well. So when you're driving through a rural area of the world, and you want to get cell service, it's not easy to get, but they're expanding that to not just say here's Wi-Fi to people that have that have that capability, or have the satellite or not, the link below, right? But also they have they can take it straight to your device, and so now you'll have connection to your handheld cell phone or laptop, or the tablets and those type of things. So anyways, that's where we're at there.
Cool. Just coming, both applications, I guess there's an element of you need to think about shielding from interference as well. Is that something you need to incorporate into your connector solutions?
Absolutely. Also? So, whether you're talking about, electromechanical interference, or electromagnetic interference, excuse me, or even, radio frequency interference, EMI, RFI, all the different types of interference that happen when you have copper power and signal running through any type of system. And so, as I think one of the best things that the products that we've worked with over the years, the interconnects that we've worked with and developed over the years, has been really how do we optimize that? And I think in the past it's been using, you have a typical cable to cable connection or a cable to box connection, and you would need to, have a lot of different added attributes to the rear of that interconnect where the cable comes in to optimize the performance of the shield, to minimize noise, or to do the other things that it can do. But I think that one of the things that we've done over the years is really try to find a way to reduce that, because that's also a weight constraint. So if you can picture, and I know I don't have any good pictures for you, but if you can picture a connector mating to a box, let's say inside an aircraft, an eVTOL, or even a satellite, and you think about the cable coming out the back end of that connector, there's a lot of dressing happening there, and that's the shield being dressed into the back shell, and there's shrink tubing, and there's all sorts of things to button up that interconnect. And some of the things that have been created over the years called the banding platform rear, instead of attaching a lengthy, weighty back shell to the end of your connector to handle all the shielding and those type of things, you develop this banded platform type technology at the end of the connector itself, so then you can dress the cable directly onto the connector and not onto another piece of metal or whatever the material is. And it also, so that allows you, first of all, you're removing something from the connection, you're removing weight from the connection, and now you're improving the performance, as you as you brought up here, so because you don't have an intermediary between a cable and a connector, where that back shell or that rear adapter might sit it's going right to the connector. So you have a first point of contact there. And so a little bit better performance, less weight, less cost, and less size as well. And so you're able to now, instead of having to thread that back shell on, you're able now to dress the cable right onto the connector. So again, all the savings, all the positive attributes that I just brought up, but also to your point, that's how you get the most optimal performance, is you get rid of as much connection in that lack of a better word, supply chain of the connector, of the interconnect product. You remove some of that and get direct contact with what's really being featured there, and then you can optimize your performance there. But again, overall though, whenever you have copper signals, and especially when you're in a tight space like a CubeSat, or whenever you're in a tight space like some of the areas of the cockpit of an aircraft, or some of the areas of the soldiers, and what they're wearing out there, you're going to have a lot of electrical things happening, and so the noise is going to be vast. And and in these critical applications, you can't have crosstalk, you can't have noise happening, you can't have other things interfering with other parts of the system or other systems within the greater system. You can't have that. So it's really important that we address those needs, and we address, but we also address the interconnect harness itself completely, fully, and as high performant as possible. And I won't say that everybody's perfected that, but I think there's been a lot of great evolution of that over the last 30 years, and so we've got that dialed in pretty well. And there's more to come, though, more evolution in terms of how we can make that improved even more, make it less weight, make it less size, make it more cost effective, that type of thing.
That's great, because one of the questions I was going to ask about that is with basically putting shielding in there, obviously that would, under normal circumstances, is going to increase the weight, it's going to add extra sort of bulk to but it sounds like you've already sort of gone quite a long way to addressing that. So there's not the trade-off it once would have been, basically, that you want to have the EMC protection, but at the same time you have to pay for that in terms of extra size and weight
Right.
for the assembly. So it does sound like the innovations that yourself and other companies have been able to make are allowing that to sort of to be dealt with. So that's quite good. Just one final application we've touched on it a couple of times briefly, but we mentioned sort of the next generation soldiers out in war zones and so forth. And as you said, that you can't have redundancy is difficult there, because you can't, the soldier, he or she has got to carry everything they've got. So all of a sudden, if you've got to have multiple connections and all sorts of other kits that is just going to add weight, then that's going to be problematic. So size and weight and power is important again. As you mentioned before, sort of IP ratings and so forth. You need to make sure if they're out in the desert, they're going to be exposed to dust and extreme heat. If they're in windy, wet conditions, they're going to have that's going to cause issues as well. Liquid ingress and stuff like that. So in terms of that, the sort of products you're developing for those sort of applications, what other things are the key attributes there, would you say?
Yeah, it still comes back to kind of that swaps,
Yeah.
Size, weight, power, and speed, and
Speed, yeah.
It's really critical with the soldiers is the size, and they're looking for micro and even nano size interconnects, and we have a great product line, our MD family of products, microcircular interconnects that we have out in the field and in market. And again, these are interconnects that are the diameter is half an inch on the US side, and I think that converts to just maybe 12 or 14 centimeters and 14 millimeters, excuse me, not centimeters, apologize.
14 millimeters, yeah.
Well, take
Yeah,
it,
that sounds right.
count on a U.S. person to screw up the metric
No,
system.
that sounds right.
But
That's about right. Yeah, it's
yeah,
about
it's about
15.
14 millimeters in diameter, and so
Yeah.
these products are fairly small. But kind of the gist of our conversation has been, how do we keep the competency of the product? How do we keep the performance of the product while we're reducing that size? And it's been a thing, an evolutionary process, but we've gotten there, and we're continuing to go down that path, even to get even a little bit smaller. And so, it's really just about working with the same materials and the same design criteria and standards, and most important, the approaches of the criticality of the applications that we work within, and being cognizant of that, to develop the product that we know and test the product up to the levels that we know will be, thoroughly trusted in the field. And so, it's just about, taking that in. And, one of the things that really had to happen over the last several years is, can you machine something with the tight tolerances that you need to machine something to, especially when you're talking about metal, or even molding some rubber or molding some plastic,
Yeah.
machining the copper contacts, and making them very small size, but still robust enough to work in the field and be field serviceable as well. You really had to not wait, but you had to make sure you had the right equipment to manufacture that product.
Yeah.
That 40, 50 years ago, in my opinion, maybe even 30 years ago, we didn't have the equipment to do some of the things we do have today. And so that's helping us evolve the products even faster. And again, so it's really about being able to, and obviously, again, make the appropriate changes we need to make to follow that swap approach of reducing size, reducing weight, increasing power when the application requires it, increasing speed when the application requires it. And so, I think that's one of the bright spots here with what we've been able to be capable of doing, is not just designing something, but actually being able to fabricate it with repeatability, fabricate it with again, meeting the standards we need to meet and the criticality of the applications we work on, so that the soldiers out there in the world can feel a lot of confidence that when they're out there, those interconnect products aren't going to be the problem for them. They're going to be able to communicate with who they need to communicate with, and they're going to be able to do the things they need to do out there. And again, have that reliability and have that comfort level that we've all been part of. All of us in the interconnect world, working in some of these critical applications, high reliability, harsh environment. We all been focused heavily on making sure that those products are top notch, and again, the tested, not just us at the interconnect manufacturing design level, but the systems level as well. All of our customers doing their testing and due diligence, and making sure that their systems are all going to work, and those lines of communication, the infrastructure's there to set it up, and even starting to use those satellites to do that communication, right, between the soldiers and up in space and back down to their, wherever they're hubbed at, their base or their leadership, and sharing those lines of communication and all that fun stuff.
Just coming back briefly to what you were saying now, I mean, obviously, as you said, I mean, based on the swap constraints we're talking about, you want to have finer pitch connectors, smaller little pieces of metal, basically tighter tolerances. They've got to be machined in such a way that, as they get smaller, the tolerances involved must get smaller too.
Yeah.
So they having the production capabilities to deal with that. Those contacts need to probably carry higher power, even though they're smaller now than they used to. So there's a material science sort of side to it. You have to work with, I don't know, developing new alloys and stuff like that to make them durable, but also high performance at the same time. So there's lots of different sort of aspects to that you need to be thinking about. So it's still an ongoing process, I guess. You need to be keeping on finding new ways of doing more with less, I guess, for want of a better word. Yeah. Okay. So
Yeah, and you
that's
think
good.
about, the whole entire semiconductor market. That's what they've been stuffed with for decades, right? Making things
True.
smaller and still more capable,
Mm.
increasing performance while reducing material.
Mm.
And that's really, we're in the same boat. The interconnect
Yeah.
market, design and manufacturing market is really, uh, I won't compare it to the active component market in terms of its capabilities and technologies and things, but we're all under the same gun. We're all under the
Mm.
same request to reduce the size and the weight and improve
Yeah.
the performance and improve the power, improve the speed. And so um, it's an ongoing approach. And like you said, and like I was saying earlier, you got to be able to, you can design a lot of things, but can it be manufacturable? Can it be repeatable?
Yeah.
And can it be field serviceable? And can it be field reliable? Is really the critical nature of it all. And so we have to work. We can't just, fly by the seat of our pants, if you will, and design something and throw it out there. There takes a lot of work in there, and especially supporting some of these markets that we talked about with satellite and eVTOL and soldier wear, and even some of those other applications out there that are demanding what we're talking about.
Great. Well, look, Scott, it's been really interesting speaking to you today, and look forward to meeting you again some point in the future. But yeah, thanks very much.
Thank you, Mike. Appreciate the time. Take care.
Take care. Cheers.
Cheers.